I have already started the screencasting. My video has, or Zoom has my video on Spotlight. So don't worry about showing your um, video by accident because it's not going to get caught in the screencast. Okay, so 18 participants. Maybe we're waiting for some more. It's only been 2 minutes since the time. Okay, but while waiting for the others, please pull up your digital notebook and go to the page where it says word wall. And while waiting for the rest, please type a word in every colored space that you learned from last meeting. So for example, I'm going to start by writing the word point. So that's one. Okay. So go to your word wall and type a word that you learned from last meeting. So fill that up. There should be at least 6. No worries, Nicholas. I had to try 6 times also before I successfully logged in today. So I tried to kind of do it at least 5 minutes before in case it doesn't work. So at least I'll have that time to text you via Remind. Okay, so what are your classmates doing if you just joined us? After typing your name, pull up your digital notebook in your drive. Look for it in your drive, pull it up, and go to the page where it says word wall. And what I'm doing is um, we are typing words that we learned from last meeting. If you guys are new to the class, um, I do screencast and I post them in Schoology every time, so you can actually catch up on the days that you missed the Zoom for any valid reason or for any connection issues. So you can actually go back to the lessons that you missed. For the digital notebook, if you didn't download from last week, I am copying and pasting the link in the chat. So once you receive it, make a copy for yourself so you can edit that one. All right, the word wall. It's in your digital notebook. If you added more pages, the page numbers may be different, but if you look at the screen, Nicholas, it should look like this. Mm-hmm. And let me just make sure I'm sharing the entire screen with you. Let me do that again. Okay, here we go. All right. Okay, so feel free to unmute yourself to contribute to our word wall. Let me start by saying a point is represented by a capital letter, and it is normally, just a dot in space, right? So anybody who would like to give us another um, word wall worthy term from last meeting, feel free to unmute yourself.
Array.
Carter, Ray. Very good. Would you like to say something about array, Carter?
Sure. So array is like a line where it has one endpoint and the other, I guess, side goes on.
Yes, that's right. That's why when you name array, you have to start by writing the letter at the endpoint, and you may take any point on either side of the array, wherever it's extending. Thank you, Carter. Next, please, volunteer. Feel free to unmute yourself. Jacob. It's okay. Any volunteer? Abraham.
Yeah.
Go ahead, Abraham.
Opposite array.
Opposite rays. Would you like to say something about that? All right, we'll go back to Abraham when he's ready. Next, please. Anybody?
Line segment.
Line segment. Awesome, Devin. Okay, so would you like to say something about a line segment, Devin?
A part of a line that has two endpoints.
Awesome. So it has two endpoints, unlike array, it has one endpoint. Okay, it consists of the endpoints and all the points in between. Thank you, Devin. Two more. And Abraham, feel free to unmute yourself if you want to speak about the opposite race already. Either Abraham or any other volunteer. We're looking for two more. Christopher. Line, sure. Please say something about a line. Cool, that's very good. So it can be named by 2 points. And if I may share with you, I'm gonna write over here on the notes part. If you have, if you have, let's say, 10 points on a line, okay, and you want to figure out how many ways you can name it, for the first letter, you can pick from any among the 10, right? But for the second letter, definitely you can't use the same letter that you used in the first. Do you see what I'm writing? Sorry, I have to ask this last time it didn't show. Just yes or no in the chat. Do you see what I'm writing on the left hand side? Yes, cool. So if you have 10 points in a line and you want to figure out the number of ways you can name it, for the first letter, you can pick among the 10 points, right? And then for the second letter, you can pick among the 9 remaining points. However, when you name your line AB, it's the same as naming it BA, right? So the letters can be, um, uh, they can commute, or the operation is commutative. So that means when you multiply 10 letters times the 9 letters remaining, which is equal to 90, this is actually double counting these possible names. So what we're going to do is we're going to divide this by 2. Okay, I'm not sure if you talked about counting techniques in middle school, but that's one, basic counting technique that I think you guys should be aware of. So that means you can distinctly name a line in 90 divided by 2 ways, which is 45 ways. And you can do the same process, um, what do you call this, in determining the total number of outcomes for, let's say you have 15 points in a line, how many ways can you name it, and so on. All right, I just thought that I should mention that because I saw it in an SAT test before, but recent changes, in colleges took out the SAT as an admission requirement. So I don't know how they're replacing that. I heard colleges will just decide their own entrance exams. Okay, so let me clear those ink so we can move on. Anybody else? We're looking for one more.
I got something.
Sure. Yes, go ahead, Abraham.
It's both the same line in it.
Cool. So they have the same endpoint and they have to be collinear. Otherwise, they will be forming an angle. And last but not the least, there's one more that we discussed last time. One more volunteer.
Um, oh, sorry, it's okay. You can
Mishka.
go.
Go ahead, Mishka.
Oh, okay. I was gonna say a plane.
Uh-huh. Please say more about a plane.
It's a two-dimensional surface, and it has an infinite set of points extending in different directions.
Thank you, Mishka. Very well said. And if I may draw it over here, now sometimes you have a parallelogram represented by 4 letters for the corners. Okay, but in the choices, let's say you have a quiz and they're naming the different planes, since a plane can be named by any 3 letters, you don't have to use all the corners. So you could just name this one as plane M and Q, or plane QRM. So if you notice, I'm going in either clockwise or counterclockwise direction, but I'm not jumping, let's say QMR. Okay, so you have to follow the order, not necessarily alpha. Sometimes there's like a small letter maybe here written B. So if that's the case, if it's not at the corner, then you could just name the plane as plane B. There you go. And if you are asked, um, to, let's say there was a question in the worksheet last time in which you're asked to draw a line inside, so you could just draw something like this, but that's not the only possibility. If they want you to draw a line that's in a plane, the line could also be coincident, meaning it's lying on top of one of the edges. Okay, so those are just some of the questions that I received through Remind, so I just thought of, going over those right now. Okay, so now we're moving on to our second lesson, which is called Measuring and Constructing Segment. So where can you find your notes for today? Go back to week number 2 in Schoology. I have a feeling I'm going too fast again, but I'm pretty sure my internet cannot catch up with me. So, all right. So in week number 2 of Schoology, there is a link um, that's called L1.2. L1.2. So go ahead and open that. I already opened mine before I started Zoom because I'm sure my internet will not be as fast as it should be. Okay, so I just published it right now. I hope it is now visible in your Schoology. Just refresh your browser. Oh, sorry, Abraham. Yeah, I normally plan my lessons, you know, ahead of time. I do have resources already. I've been teaching for so long, but I try to like hide them first. So, um, yeah. Okay. So this one has 5 slides. Okay. Please don't feel that we have to or you have to do all these. I just want to be more mindful of, you know, um, your difference in terms of speed. So some need more help, some are ready to move on. So if you find me too slow, just keep moving on through the slides and you will see what you have to do next. Okay, so I added some exercises that you guys will do. All right. So I did mention some counting techniques earlier, but something for you to, kind of look forward to when you go to your next math class, which could be Algebra 2, okay, or statistics. That's crappy. It's combination. Okay, I meant to write combination. Okay, so the technique I taught you earlier on how to count the total number of ways to name a line is actually a lesson in statistics. It's called permutation and combination. Now, I just want to be like transparent here when it comes to note taking. I did mention that you have to show evidence of your work. So if you are working on a piece of paper, you're good. If you're not and you want to wait for me to like finish everything and to take a screenshot of the whole screen, that's up to you. But my priority, your priority, should be to learn as much from the lesson. Okay, so I do screencast anyway, so you can go back to them, right? So my bottom line is do what works for you. So don't take down notes when you feel like this is too much. I can't do it. I can multitask and so on. All right. So your priority is yourself. Okay. So I hope that we'll have time at the end of, the second semester to talk about some statistics lessons. We'll get to that. Okay, next. On page 2, every time you see this link, I strongly encourage you to practice drawing in GeoGebra, or you can do it by hand on your paper. So again, when I say draw, do what works for you. Okay, so what's the first thing we're going to talk about today? We're going to talk about the ruler postulate, and it's just a fancy way of talking about the number line. So if you have over here, if I could read it for you, the points on a line can be matched 1-to-1 with the real numbers. So it's like you're drawing a number line and you're putting the numbers assigned to it. The real number that corresponds to a point is the coordinate of the point. And if you remember in algebra, if you're plotting on the xy plane, a point has 2 coordinates. Okay, I'm going to show you how you can create some images in GeoGebra in cases when you have to submit a worksheet and Cami doesn't work for you or it's not installed in your browser, etc. Okay, so go to geogebra.org/geometry. I'm also going to send that in the chat. If you can bookmark that page already, that will be nice. Okay, so we're going to draw a number line and label them with their coordinates x1 and x2. All right. Okay, so we can simply like Google an image for that and then just paste it. I know, but just so we're familiar with all the tools that we can use. Okay, so first we're going to draw a line. So click on your line tool and then start at any blank space on the white screen. Okay, and this is where you can find some, ways to write a text or a subscript. Let me know if I'm too fast. I'll give you some 15 seconds wait time. You can also do this in Google Drawing. You can also use it in Word. However, if you were with me in Algebra 1, I do have some Google Sheets or Google Forms for in which you have to use decimals for discovery and stuff like that. So that's what I'm preparing you for. In geometry, I do have a lot of discovery stuff as well that you need this platform for. Okay, so I clicked on more. There was a option here to click on more and then go to text. Go to text right here. Okay, and we're just gonna do this, once. So, okay, go to text and then you click on point A, double click rather. You double click on point A, a pop-up will be shown like this. Now you click on advanced. Let me know if I'm too fast. Click on advanced and then latex formula. All right. And you will see some of the options here if you want to type a symbol. Now, what we want right now is to place a coordinate using, or by naming it x sub 1. Okay, because that's the formula that was used in the figure on the slide. So click on x sub 2. So this pretty much shows the subscript inside the two braces. So it's like x sub, and then you want to name the first one x sub 1. All right, let me take this out of the way. Okay, and once you have that, you click OK, and it should automatically pop up on your screen. All right. Now do the same thing for, okay. What's wowzers? Sorry, I only know old school English. English was even my second language, Madeline, so. Okay. All right. Is that like a new word for something? All right. Hang on. So, point B. Yes.
How do you get out of that?
Oh, you know what? You have to like drag it upward so you can find the OK at the bottom. Yeah. You got it? Okay. Now we're gonna do it again. So if there's one thing that we would get from this online learning is if you are going to attend college and you have to make like school papers and stuff like that, you have to learn how to like type back symbols because yeah, and doing office work as well, you have to be proficient in typing or computer, etc. Okay, so I need x sub 2. There you go. So do the same thing. Click on advanced latex formula x sub 2 and click OK. And as I've said, we're not going to do this the whole period. So I just want to show you, okay, how you can do it. All right. So what you need is take a screenshot of what you drew. You know, I do have a snipping tool at the bottom of my screen. If you're using a Chromebook, it's Control Shift. There's a rectangle above the number 6. Okay, so screenshot what you drew, and then now you paste it right there and drag it over to the left hand side. Okay.
For Chromebooks, you don't need to do Control Shift. You could just do Control.
Oh, thank you. Was that Mishka? Right? Madeline, I'm so sorry. Okay, Madeline. Thank you for sharing that. Yeah. So control and then, oh, cool. All right. So x1 and x2 are the coordinates. Okay. Yes. Uh-huh. You do. Madeline said just use control.
Yeah, and
Yeah. Yes. Well, you guys are better than I am at this one. Cool. Okay. So, um, in relation to that ruler postulate, if 2 points have their coordinates, then we can actually find the distance between them. Okay, and that's what we're going to do later on when you look at, I think, slide number 4. Okay, all right. So after drawing, let me just read the next prompt over here, which talks about the distance. So the distance between points A and B, which is written as AB, okay, so no bar on top of the 2 letters, is the absolute value of the difference of the coordinates of A and B. So what does that mean, pretty much? I'm going to draw something here. You don't have to copy this because we will have an example later on anyway. So suppose I have the number line, and this is A, this is B. Let's say this is -8, and that's on 5. Okay, so how do you find the distance from A to B? Which in symbol, instead of using X in algebra, right, we now say, oh, AB. Okay, AB means the distance between them, which is also the same thing as BA, because remember the letters can commute, but no bar, no bar. Okay, so it's actually equal to, the formula says, get the absolute value. Okay, so let's put that absolute value symbol over there, and then you get the difference. Okay, difference is subtraction, right? But how do I know which comes first? Well, it doesn't actually matter. Let's say I want to do the -8 first. So -8, and then minus, because it says difference, then 5. There you go. Okay, and then you go absolute value again, off. -8 and -5 is -13. But the absolute value of any negative number is actually positive. So the correct answer is +13. There you go. Now, alternately, you can also just count from -8 to +5, right? Let's say -8, and then you count backwards all the way to 0. So that's 8 spaces to the right, and then you count 5 more spaces to the right. That's 5. So it's actually also the same answer that we get. All right? So the case is similar when you have a vertical line, and that's what we're going to look at next. Okay. So, oh, by the way, I want to mention that earlier somebody asked me, Miss, can you pause to, to give us time to screenshot what's on the screen and then we paste it on our notebook? And I said, sure, if that works for you, so you don't have to rewrite them. I know it's kind of hard if, you're writing and learning at the same time. So, okay, I'm going to pause and
well, so do
yeah.
you want us to write down that still?
If you want to write it down on your paper, or like right now, if you're not busy, you can screenshot, right,
Yeah.
and then just paste it on that page of your notebook. Does that make sense?
Okay.
Okay, honey. Yep. And that's faster, so you can at least just focus on your screen. Okay, so now in the next one though, you have to do some work. I think I went to the wrong slide. Okay, so go to slide number 5, and I want to show you only one of these 3, so you can do the rest later on. I want you to plot these, not on paper though. Go to GeoGebra. That's your friendly grapher or graphing paper. Go to GeoGebra. You can delete everything there that you drew, or you can actually start on a new one. If I may start, let me know if I went too fast. Show your grids. You can just show the major grid lines, or if you want, show both, um, minor and major, whichever you guys want. And then show your axes. Okay. You can zoom in and out however you want it. All right. So now I'm going to teach you how to plot the points. To plot the points, you can plot them manually, or you can go to the calculator tab and type the coordinates of the points. So the first one is, okay, -5, 5. So let's do that. Maybe I can make my GeoGebra smaller so I can copy those, right? Okay, so let's plot uh, -5, 5. Okay, I think I put that. All right, okay, that's your point A. And then plot point B, because remember they are alphabetically named by default. So let's put another point, -2, 5. That will be your point B. Okay. Then point C.
How did you get the
Oh, sorry. Oh, this one, honey. Click on the gear symbol and then show grid. I I chose the major and minor grid lines and then show axes. Okay. There we go. All right, and then where was I? Point C. 2, -4. And the last one is -1, -4. Oh, did it type? -1, -4. All right, and you should have something like this. Oh, sorry. Right there. It's right here. Do you see them now? Okay. Mm-hmm. And I think there's a way to split the screen in your Chromebook. I just learned it recently. You just like drag one tab until there's like a faint box that appears in half of your screen. And then do the same thing for the other one. Right now I'm using my computer, so it's different. Okay. All right. Going back, now let's draw the line segments. Because it says we have to determine whether segments A, B, and C, D are congruent or not. And that will lead us to what we're going to define next. What are congruent segments and so on. Okay, so going back here, I want to be able to draw the line segment between them. So I'm going to toggle to the other tool again, the geometry tool. There you go. And then you click on your segment tool and go from A to B. There you go. And then the other one is from C to D or vice versa. All right. Okay, you do need to capture this image and paste it already in your individual work page. So let me just do that right now. So let me do this. All right. And then paste. Okay, so there's my image already. All right. Yep. The grid. Sure. Oh, sure. No worry. Let me just find it because I know I. There you go. Do you see it?
Yeah.
Okay. Okay.
How do I find the points?
How do you plot the points? Okay. You see this calculator thing, honey, right there? You see it? You click on that one, and then you gotta type one by one. Does that make sense?
Yes.
Okay. Yeah. So you just copy the points right there, one by one. Go in order though. So the names of the points will also be A, B, C, D in that order. Okay. And later on, when you do letter B, or number 2 in your independent work, just change the numbers here because if you add more rows, what do you call this? That will rename them using different letters. Okay, so and the segment that you drew actually also appears also here. So if you want to delete that, you could just change, or you can just, click on those three dots and choose delete. Okay, in case you want to redo everything. Yeah, already. So before we go to the definition of congruent segments, let's just make a guess. Just by looking at them, if I count the number of boxes from A to B, that's like, 1, 2, 3, right? And if I count the number of boxes from C to D or vice versa, it's 1, 2, 3. So what does that tell me? Are the segments congruent or not? Well, obviously they are, right? And what is the definition of congruent segments? So sorry if I went too fast. Let me pause for 10 seconds. Um, I did kind of scramble my slides. I'm sorry about that. I switch around 4 and 5. If you want to drag 5 and move it up, that will be nice. So they're right next to each other. Okay, so before we write our conclusion here, let's talk about congruent segments by going back to slide 3. Slide 3. Okay, so segments that have the same length or measure are called congruent segments. So you can highlight those if you want to. If not, that's okay. But what I would like you to focus on is how to insert the congruent symbol. And you can also make the font bigger if you want to, change the font, etc. Okay, so let me teach you where to find this symbol over here. Okay, so the symbol blank means congruence. Well, right now you could just copy and paste it from this slide whenever you need it. Or I'll show you where to find it. Let me delete it first. Okay, so the symbol, and then I go to insert, special characters, and then something will pop up. You can actually draw in this blank box over here. Start with an equal sign with a twiddle on top, with a curly thing on top, and it will match that with whatever it has on file. So click on that, and it will automatically insert that symbol for you. Okay, you can do that with greater than as well. It will match it, or greater than or equal to. And that's very useful when, or you can type in a keyword and so on. Okay, so that symbol means congruence. So in the example that I was showing you earlier in the slide, I don't know if you move it up to slide 4 already. Okay, then we can say that segments AB and CD are congruent because they have the same length. So when we counted the boxes, they are actually, um, they use the same amount of units or boxes. Another way to do it, though, if maybe you're wondering, where does that absolute value formula, come from? So if this is, let's say, this is -2, right? So the x value here is -2 comma 5, and this one was -5 comma 5. Okay, so we could also get this answer here, which is 3, by using the absolute value. So we say the distance from AB is the absolute value of, and then since it's horizontal and they do have the same y coordinate, so if they have the same y coordinate, just ignore that, because we're simply counting the number of boxes across. So what we're going to do is pick one number to begin with, -5 minus, but that number is -2. So you're going to have another -2 right there. Yeah. And these two negatives will cancel out. So you'll have -5 plus 2. And that's where your absolute value of -3 is coming from. That's why when we counted the boxes, it's actually 3. There you go. I know this is a long method, but um, you know, it's just realigning what we know from algebra, like counting the boxes, with the ruler postulate in geometry. Okay. All right, so that's one example. If you want to screenshot that one, go ahead. If you need to see that later on, before I move on. Okay. Now, just to kind of complete your graphic organizer as well, I'm gonna switch. Okay, so you did paste a picture over here of congruent segments. So you copy that again and place it in your vocabulary page. So it says you um, put examples, list examples, or add an image. So you can already replace that by the image that you drew. There you go. And put it right there, resize it if you need to. Okay. I'm not going to be very specific with that. You can Google, you know, congruent segments or something like that. If you want to do that, that's fine. Okay, but I just wanted to make sure that you know where you can get stuff from. Okay, and as you do the other examples later on, I'm pretty sure you will encounter something that's not congruent, segments that are not congruent to each other. So then you can paste that here in the non-example portion. Okay? And you can leave this blank because we don't need it yet. I'm going to give about 15-second wait time before I close that portion on congruent segments. Questions if you have any.
How do I add points?
How do I add points? Okay, so let me show you where we're going to copy the points from. You're going to look for this slide. Originally, it was slide 5, but I move it up. And then in your GeoGebra, let me clear this ink so it's not confusing you. Clear ink. Okay, so you click on the calculator part, right? Let me delete this for you so I can illustrate that clearly. Or I'll just add another one here because my computer is slow. Okay, so I know I should have made up my mind, computer. Hang on. So, all right. So let's say I type another one here at the bottom and delete that. So you're copying the points over here. Let's say -5, 5. So you just put parentheses and then -5, comma, +5, close parentheses. Does that make sense?
Yes.
Okay. Yeah. And it would be nice if you can start from scratch so the letters will be named accordingly. Okay? All right. I'm going to close this now. My computer is slowing down already. So leave. I don't need you anymore. Okay. There you go. Okay. Um, the next part for today's work is called the segment addition postulate. Segment addition postulate. And I'm going to write a lot of stuff in here. So maybe pay attention first and then you screenshot what I'm going to write later on. So, or you can draw your own nicer version. Okay. So, in the segment addition postulate, I'm going to draw a line segment. It says B is between A and C. A and C can be interchanged. And in geometry, betweenness does not necessarily mean right at the middle. Okay? It could be closer to A, it could be closer to C. It could be the middle, of course, but not necessarily. All right. So if you want to get the total measure of this line segment, we have what we call a segment addition postulate. What is a postulate, by the way? A postulate in geometry is just like hypotheses in science. So we just accept it, even without proof. Okay? I know in science you verify your hypothesis. So in geometry we can verify it. We're not going to prove it. We just accept it as it is. Okay. So based on this image, the shorter segment AB, when added to the longer piece, which is BC, altogether will give us the entire segment AC. Okay. Now the converse, here's another word. The converse is also true. So what do we mean by converse? I'm going to write the converse over here. In geometry, converse is actually switching the if and the then part. Okay, so for example, in the original statement, I know you may think that it sounds like we're studying structures of sentences in English, but it's only the if then. I'm not even good at English, but it's just the if then portion that is very important in geometry. So in the first example, the if part or the hypothesis part is B is between A and C. Okay? The then part is AB plus BC is equal to AC. So converse is you switch them around. So if we switch them around, it's going to look like this. If instead of B is between, you take the other part, you take the equation portion. AB plus BC is equal to AC. Then, and then switch the other part. B is between, and maybe you're wondering, okay, what's the point of this? We probably may not see it yet, but once we start proving, it will begin to make sense. Okay, so if AB plus BC is equal to AC, then B is between A and C. So which is pretty much the reverse of that one. Okay? All right. Okay, so how do we use that postulate in computations? Okay, and that's all we're gonna look at next. Oh, chat. Okay. Oh, yes. Go ahead, take a screenshot. We started at 1:15. I mean 1:05. So the time, I don't know like the actual time, but yeah, we'll be ending soon. Okay. Live is between 40 to 45 minutes, so we should be like done before 2 o'clock. Okay. All right. So, which leads me to my last one, by the way. Oh, did you have enough time to screenshot? Okay. I'm going to clear the ink. All right. So, how are we going to use that in computations? So, let's have an example. This is the last slide we're going to do. If A, B, and C are collinear, so let's make a diagram for that one, with B between A and C. Okay. So, B somewhere here. And AC is 3x plus 3, so the whole thing, right, is 3x plus 3, while AB is negative 1 plus 2x, while BC is 11. Okay. And then the whole segment is 3x plus 3. So if we write an equation, we have AB, that's a shorter segment, plus another part, BC, is equal to AC. So by substitution, AC is 3x plus 3, while AB is negative 1 plus 2x. And then BC is 11. Okay, so we started with a segment addition postulate, which is this equation over here. And just like what we did in algebra, we substitute the given quantities. So now we just need to combine like terms and solve it. So combining like terms, we get negative 1 plus 11, that will become a 10, right? And you bring down the 2x. And then bring this down from the right hand side. And if you combine like terms together, you can subtract 2x from 3x, you get x, and then subtract 3 from 10, you get 7. So the value of x is 7. All right, so that's how you use the segment addition postulate. And last but not the least, I'll leave this one for you to try later on. And last but not the least, sometimes the segment is divided into 3 portions like this. First, second, third. First, second, third. So we just add all of them together. Like nm, which is x minus 6, plus ml, that sounds like Mobile Legend, ml, plus lk, I forgot my l, which is 2x minus 19, equals the whole segment, which is nk, which is given by 23. And just do your algebra and combine like terms. X plus 2x is 3x. Negative 6 plus 9, that's positive 3. Positive 3 minus 19 is minus 16, is equal to 23. Okay. Then just move your 16 over. 23 plus 16, you'll get 39. So your x will be equal to 13. All right. Okay, and those are our three main points for today. The ruler postulate, which is pretty much the number line. The absolute value distance formula, which can be used when the lines are either horizontal or vertical. And last but not the least, the segment addition postulate, which can be used when a segment is partitioned into smaller pieces. Okay, so for your homework, they are in Delta Math. Oh, did I give you enough time to screenshot that one? I'm sorry, I forgot. So before we go, if you already know where to find your homework, you're free to leave. If not, stay behind so I can show you. I recently purchased an upgrade to the Delta Math. So even if I'm not there to help you, there are some videos built in to guide you. Okay. Is Delta Math daily homework? Not kind of daily, but if it has some that's related to our lesson, then I will assign, a homework there. Uh-huh. And it's going to be recorded every grading period. I will be copying your average into Schoology. Oh, we have two so far, honey. Yes, and they're all due on Monday. So I thought of, yeah, making them due the Monday the week after they are assigned. Okay.
So the one there is supposed to be 1.2 segment addition.
Yes, honey. Uh-huh.
That's the one there. Okay.
Okay. Yes, I will send you the link right now. Give me one sec. Okay. There you go. That's the link. And then you go to create account, and click on student. Now the teacher's code, it's in your digital notebook, but copy it now so you can set this up and you don't have to worry about finding it. 918819.
Okay. What is it here? Added.
Yeah, you may go. Yeah, you may go, honey. Happy weekend, guys. Please stay if you need help.
Okay.
Bye. Have fun. Okay, so the teacher code. You too, honey. Bye. Bye, Abraham. Bye. Have a good one. You too, Ismael. Okay. Bye, Devin. Okay, so the code is 918819. Uh-huh. If you guys still need to set it up. And then you just click the period that you are in. So you are in my period 6. So just click that, type in your information, and you should see 2 assignments that are due on Monday. Okay. All right. Did you get that, Kota and James?
Yeah, I already did some of the assignments, but
Cool. But go ahead, honey. I'm listening.
I just joined today because I just switched classes recently.
Oh, okay.
I mean, not
So
classes, switched schools.
cool. Okay, I'll walk you through like where you can find stuff. You got it, Coda? Okay. What does that mean? Okay, so James, let me walk you through your Schoology. Do you have access to Schoology already?
Yes, so I've done some of the assignments.
Oh, that's cool. Then pretty much if you've done everything that you've seen on Schoology, that's pretty much it. I have a text group so you can message me anytime in case there's connection issues. So there are instructions on this page. The All About Me slide, did you download that already?
Uh, well, it's that was on that's the digital notebook, right?
Yes, yes. So if you've downloaded that, you don't have to do it again. There's a slide there that I designed about myself. So what you're gonna do is you change it, you revise it, you edit it, so it will become yours. Does that make sense?
Yes.
Yes. Okay. And then every time that I push new slides like today, the slides I use for the lesson, what you're going to do is you just go to a page in your digital notebook where they should go. So you can place that underneath like the first lesson. I don't know if you were here when I did the first lesson. If you weren't, I can I can show you where you can find those notes. You see this one, L1.1.
Yes.
Yeah. So every time you see like a letter L, those are new slides for the lessons. So what you're going to do is in your digital notebook, like they are just arranged like this. So um, all you need to do is go to File. Let's say click on the slide where you wanna add more slides after, and then you go to File and then Import Slides. And once you do that, it will automatically link it to your Google Drive where you can find those pages that you want to add. Okay. Let's say you want to add the lesson for today, lesson 1.2. Just click on that and it will automatically add it to your digital notebook. Does that make sense?
Yes.
Yes.
I was confused on like the homework. There's like you said something about adding the three equations.
Mm. Yeah. So, like in today's notes, for example, where was I? In the example that I last showed, oh, I have to open it again because I already closed it. Give me 1 second. My computer is slowing down right now. Let me close this digital notebook. So sometimes like a line segment is cut into three pieces, right? Did you
Yes.
yeah, did you see the last example I did? So if that's the case, then you are going to add all those three little pieces. Let me go to slide